First of all, let's look at the concept of a logarithm. For b greater than 0, b is not equal to 1 and x greater than 0. These two forms are equivalent to each other. Logarithmic form log base b of x equals n is equivalent to exponential form b to the nth power equals x. For the exponential form, we know this b is a base. This n is an exponent. B to the nth power, we call is a power. For the logarithmic form, b is a base. This x is an argument. For this n, from exponential form, we could say this n is an exponent. In other words, log is an exponent. For the parent function, y equals b to the x power, we know domain is all real numbers and a range. Since we know b to the x power always greater than 0, so the range is y greater than 0. There is a horizontal asymptote line for exponential function y equals 0. For logarithm function, y equals log base b of x. Since exponential function and a logarithm function are inverse functions, range of the exponential function will be domain of a logarithm function. That is x greater than 0. The domain of a exponential function will be the range of a logarithm function. Y is all real numbers. There is a vertical asymptote line in logarithm function, that is x equals 0. For exponential function, when x equals 0, y will be 1. Since logarithm function is the inverse function of an exponential function, 1, 0 will be on the graph of y equals log base b of x. Remember, for exponential function and a logarithm function, the base is always greater than 0. The base is not equal to 1. Look at number 1. Write an equivalent exponential equation for a log base of 100 equals 2. Remember, when you switch from logarithmic form into exponential form, base never changes. Therefore, for a, we can write down 10 to the second power equals 100. For c, we can write down 5 to the 1 over 4th power equals 4th root of 5. Let's go to number 2. Write an equivalent logarithmic equation for a, base never changes, log base 4 of 1 over 16 equals -2. Log is an exponent. For b, log base b of 1 over cubic root of 6 equals -1 over 3. For e, log base b of b equals 1. F, log base b of b to the nth power equals n. This is a very important formula to solve exponential equations. Now let's go to the very important formula for logarithm, change of a base rule. Log base b of a equals log base c of a over log base c of b, or it equals common log of a over common log of b, or equals natural log of a over natural log of b. Common log of x means log base 10 of x. Natural log of x means log base e of x. Number 3, use change of a base formula to prove 1. Log base b to the nth power of a equals 1 over n times log base b of a. Just check on the right side. Base is b. Left-hand side equals log base b to the nth power of a equals log base b of a over log base b of b to the nth power. We already know log base b of b to the nth power equals n, because b to the nth power equals b to the nth power. These two forms are equivalent to each other. Therefore, we will get denominator is n, log base b of a over n. That equals 1 over n times log base b of a equals right-hand side. So we finish proving. Let's go to number 2. We want to prove log base a of b equals 1 over log base b of a. On the right side, we know base is b. So we will change the log into the log with the base of b. Left-hand side equals log base a of b equals log base b of b over log base b of a. That equals, we know b to the first power equals b, which means log base b of b equals 1. So we have 1 over log base b of a. This equals right-hand side. Let's go to number 3. Log base b to the nth power of a to the nth power equals log base b of a. Left-hand side equals log base b to the nth power of a to the nth power. According to the first formula we just proved, we get 1 over n times log base b of a to the nth power. Since we need to deal with a to the nth power, let's change all the log into the log with the base a. 1 over n times log base a of a to the nth power over log base a of b equals 1 over n times log base a of a to the nth power, that is n, over log base a of b. Then reduce, we will get 1 over log base a of b. According to the second formula, that equals log base b of a equals right-hand side. Let's go to number 4. log base a to the nth power of a to the mth power equals m over n. Left-hand side, we will change the base into a. So we have a log base a of a to the mth power over log base a of a to the nth power. That equals m over n equals right-hand side. This is a very important formula. We will use this formula to evaluate the log without graphing calculator. For number 5, log base b of c times log base c of a equals log base of b of a. Left-hand side equals log base b of c times. Since the base of log on the right side is b, we will change all the log with base b. So we have log base b of a over log base b of c. Then reduce. We will get log base b of a equals right-hand side. From number 5, we can figure out this formula. Log base b of c times log base c of p times log base p of q times log base of q of a. Then we can cancel this c, p, q so that we can get the log base b of a. This is a very important property of logarithm. Please remember.